My name is Joseph Martin, and I did my additive manufacturing project on direct metal laser sintering, also known as DMLS. The preliminary steps for DMLS, like many other methods of additive manufacturing, DMLS uses a CAD model as a mode of replication. The printer needs a 3D model and appropriate software that is compatible with the printer to splice the model into thin layers to print. One of the preliminary steps includes determining what powdered metal you want to use. Depending on the application, there are dozens of different powders you can use, and each one of them has different properties. Some of them are stronger, some of them are lighter, different costs. Uh, Different metals and alloy powders are used throughout industry using the DMLS method of additive manufacturing. Materials can include aluminum, Inconel 718, stainless steel, and titanium. The aerospace industry uses titanium a lot because it's really strong for its weight. Metals vary in price and benefits and pitfalls. The hopper of the DMLS machine should be filled with the powder you require before printing starts. The process. There are two platforms in the DMLS machine, the build platform and the powder dispensing platform. The build process starts with the build platform in its highest position. On the right side, it'll be in its highest position. The first layer of powder is dispersed onto the build platform by the recoater arm centered on the base plate. As the build platform lowers very slightly, the recoater arm coats a thin layer of powder back onto the build platform onto the centered part. The laser centers another layer and the process repeats into completion. So as the layers on the right side form, to add a new layer, the build platform lowers, the recorder arm coats the top of the part, then the powder dispensing platform raises, and it repeats until the part is completed. Post-processing. Heat treatment can be required after the part is printed and before removing the object from the build platform. This can involve heating and cooling the part at regulated temperatures. Support removal can be difficult and may require the use of machinery and tools to remove the support material, which may lead to surface finish defects, which you may need to get polished or grinded at that point to have a smooth finished surface. Excess powder would need removed from the part and thrown away or reused at the manufacturer of the machine advises that you can reuse the unused powder. In some circumstances, you may need to pitch or scrap the unused powder that you removed from the support material. Going over the history of DMLS, initial research on DMLS came in the 1970s. The first patent on this technology came from ERD and EOS in 1994. The first commercial system was shipped in 1992, named Center Station 2000 by the DTM Corporation and colleagues at the University of Texas. The second commercial machine was made by EOS and named EOS INT P350 and initially shipped in April of 1994. Over the years, significant improvements in layer thickness, laser, material, and processes have greatly been improved. Advantages. DMLS can create complicated geometry and may be the only method of manufacturing a part versus using traditional manufacturing. A variety of metal and alloy powders can be used with a multitude of different benefits. Topology, structure optimization, higher strength and lower weight when compared to traditionally manufactured parts. An assembly of parts can be printed into a single part. An example of that is a fuel nozzle in the aerospace industry. What took probably dozens of parts being assembled could now be printed and make one in one single step, and a significant cost savings resulted from that. Disadvantages: metal 3D printers are all for industrial use only and can cost over $250,000, which can mean a very significant upfront investment. Material powders such as stainless steel can cost $350 to $450 a kilogram. Small build size when compared to traditional manufacturing and other processes such as FDM. You're pretty much constrained to the size of the machine you're using as far as DMLS goes. As for traditional manufacturing, you're almost limitless in potential. Audio applications. Aerospace and high performance racing often use DMLS to reduce weight and retain strength. Just a very slight weight reduction can be the difference in a tight race. The medical and dental field use DMLS for metal inserts that can be inserted into patients to promote bone growth and making crowns and other dental implants. Complex parts can be manufactured through this method throughout all industries. Plastics industries uses technology for injection molds as far as inserts and rapid tooling. The major players in DMLS. There are several companies that manufacture DMLS machines. However, the biggest and most notable are 3D Systems, EOS, SLM Solutions, and GE Additive. I think I mentioned this before. Some examples: SpaceX owns several DMLS printers that use this technology extensively. One component specifically is the main oxidizer valve body and one of the 9 Merlin 1D engines. The picture on the right shows a fuel nozzle that was metal 3D printed. Estimated cost of DMLS. As mentioned in the previous slide, the upfront cost for the machine can be anywhere from $50,000 to over $1 million. Material cost can range from $300 to $600 a kilogram. I believe titanium might be the most expensive. Highly trained personnel should only operate this equipment. Training time and costs need to be factored into this training. In some circumstances, the cost of the machine itself may account for as little as 40% of the total expense of using this method of manufacturing. The outlook of this process. Future market trends for this process are proprietary regarding being able to find research for an outlook. I looked through several websites and pretty much they wanted you to buy a subscription to read their articles concerning the future market trends of the technology. Currently, this technology is limited to prototyping, production tooling, and specific parts. For this technology to expand even further, work needs to be done to improve the DMLS printers to open up to a broader market. The technology is proven, however. Conclusion. DMLS is ideal for specific industries and needs. DMLS is ideal for parts that are either complex or impossible to fabricate traditionally. It's possible to reduce an assembly of parts into a single part. Concerns over strength and weight. Rapid tooling such as mold inserts. The upfront cost is high and the production is slow. There are size constraints of this process, depending on the size of the machine you look to purchase. And many manufacturers will steer away from this technology because of all this. It's really kind of a niche space. If you don't have a specific use where, you could, like the aerospace industry, or the racing industry need high strength, low weight, or stuff like that, where you could really justify purchasing a machine for a specific need. These machines, like I said, will cost you hundreds of thousands of dollars. Here are my sources. Thank you.